Here we go. Alright, so chapter 3, mass weight. Dylan, what can you remember? Mass is the?
Amount of matter in object.
Good. Amount of matter in a body. Okay, Shahir, weight is the? Can you remember or not?
The gravitational force acting upon an object.
Yes, very good. Gravitational force acting on an object or body. Okay, then of course you all will remember the formula lah, which Jonathan cannot remember lah. W equals mg, right? And then G stands for?
Gravitational center.
Yep. Okay, and on Earth it is? 10 meter per second squared. Okay, so very familiar. Huh? And the differences between mass and weight, they like to ask you about differences. Most of them you know. One, mass is a scalar quantity, weight is a vector. Okay, so you already know what's a vector, right? Anyway, next week we'll draw a vector diagram.
What's that again?
Huh?
I forgot the vector and scalar. What's that?
Vector are quantities which have, what is it?
Like magnitude and direction.
Magnitude and direction.
Oh.
Right? Then scalar only has magnitude.
Yeah.
Right? So weight is a scalar because let's say you have this object, the weight is, arrow is pointing down, right? It's a direction. Whereas things like mass, where got amount of mass in a body, right? How can it have any direction? Okay? So then the other differences you can read for yourself lah, quite obvious lah. Okay? And then the units, of course, this is kg, this is Newton. Okay, so very simple. Okay, more difficult under this section is these definitions, these two definitions. Try to remember because they are harder to remember. Gravitational field is the region in which a mass experiences. What does it experience?
I don't know, a pool.
A pool is known as a pull or a push is examples of a force. So experiences a force due to obviously gravitational field strength. So due to gravity. Yeah. Okay. Then so there is one definition. Then gravitational field strength itself. Gravitational field strength, the symbol is G, right? Or I always call it gravitational acceleration. So this one is the acceleration due to gravity. Okay? Simple definitions to remember. Okay, then density definition. Dylan can remember. D for Dylan, D for density. Density is the? Can remember the formula or not?
No, what density?
Aiyo, so easy to remember the
Such an
formula.
irrelevant topic of the
Irrelevant.
never
So E equals to M over V.
Okay,
yapping about.
density equals to M over V.
Oh, that formula. I quite remember it like.
So you can remember the formula, you can remember a definition. Just look at the formula, tell me. Density is the?
Mass mass per volume.
Mass per unit volume.
Oh,
So easy, right? Just remember the
Yeah.
formula, you remember the definition, right?
I always knew it, man. I just didn't want to say it.
Yeah, that's true. Okay, so it's either gram per cm cube or kg per meter cube.
kg just times 1k, right?
Okay, this one you gotta be
Just
careful.
the flip around.
This one you gotta be careful how you convert. Okay, I'm going to talk about that. Okay, you see, for example, you look over here, the examples. You see, aluminium, okay, 2700 kg per meter cube. Gram per cm cube is only 2.7. Okay, so your conversion how does your conversion go? You're dividing. So if let's say I say go from gram per cm cube to kg per meter cube, over here to here, you times by 1,000. Then if you're going the other way round, you divide by 1,000. So here you gotta be careful. Why? Because a lot of people will think the other way around. Because they're just thinking, oh, 1 gram, 1 gram to kg is divide by 1,000 what?
This one only applies to density.
That is correct. 1 kg, gram to kg is divided by 1,000, but this is gram per cm cube, and this is kg per meter cube, not the same, right? So this is times by 1,000. Okay, just remember that. Okay. So watch out, don't convert wrongly. So what does it mean if let's say something is 1 kg per meter cube? Didn't 1 kg per meter cube is equivalent to? Divide times.
0.001.
Yeah. Okay. Then 1 gram per cm cube, you times it, it becomes 1,000. Right? So watch out all this.
Oh my god.
Okay, next, convert 1.2 gram per cm cube kg per meter cube. What is it? Shahil?
It's 1,200.
Yeah. Okay, you go by this, then this is simply 1,200 kg per meter cube. Yeah. Then they learn the other one. 19,300.
19.3.
Divide times.
Divide, right?
Yeah, divide. Yeah.
19.3.
Yeah. Okay. So not too difficult just be careful Okay, next page. Wow, what is this?
Words.
So many words, exactly. Okay, I hope they don't ask you this. So if they ask you find the density of a liquid, how do you find the density of a liquid? Okay, each step of the way. Right? Maybe you do it in a lab. You are finding steps 1 and 2. What are you doing? You are finding the mass. Yeah, you read for yourself. You're finding the mass. It's quite commonsensical You just have to write quite a bit Find the mass of the empty measuring cylinder. Okay, they found it 82. Then after they pour the liquid in, then after that they put it on electronic balance. Then after that you find the difference, you get the mass. Okay, then obviously the measuring cylinder will tell you the volume. So this part will tell you the volume. Then this part will, in the end, you get the density by calculating. Okay, quite commonsensical. Just do it. Just describe step by step. Not difficult. Okay, if it's a solid, when you do this in the lab, often what happens, you guys will break all the measuring cylinders. Okay. Or then after you put the solid inside, the solid cannot stuck inside the measuring cylinder, cannot come out. Often give you all the plasticine, right? Then you mold the plasticine, put it inside, and after it gets stuck. Or worse, sometimes they use a rock, put inside, whole thing smashed. Okay lah. Anyway, it's very straightforward again. Right, so the solid, you just use electronic balance, find the mass, find the volume, just find the difference in the two levels on a measuring cylinder. Or you can use a displacement can. You know what's a displacement can? Can you remember what's a displacement can?
It's near like that one setup where like there's like a large beaker. It's like then the liquid level is like somewhat like it's almost near the opening. Then you just lower the solid inside. Then the excess water there is into the beaker. Is basically the volume of the solid.
Yeah, you're right. Something like that lah. Okay, Dylan. this one you put the stone inside here, then after that all the water will flow into here, right? And then from here you can read out the volume. So this one here is called the displacement can, right? Then you can put it a magnetic cylinder here, water displaced, just get it. Very easy lah. Usually they won't ask you describe lah, but even they do also, it's not too difficult. Okay. By the way, I ask you, to my surprise, a lot of students don't know this, but since you all study in school, I think you should know. Let's see.
What's this?
What does the mass volume graph look like? For any solid, liquid, curve, straight line, flat line. What?
But doesn't the mass not change?
Mass don't change, Okay, the mass don't change.
I don't know.
What?
Wait, the mass of what?
So-
This is cool.
So if you have one object, all these are the same mass. I mean, all these are the same density. But obviously, the mass and the volume is getting bigger and bigger. What doesn't change? The mass is definitely changing, the volume also changing, but what doesn't change? All of them are same material. So
Density.
the density don't change, right? So if the density don't change, so you know density equals to mass over volume, right? So you see so mass equals to density times volume. So this one is the same, it doesn't change. This is the gradient, right? The gradient is same, right? So m go up, v go up, m go down, v go down.
So it's just constantly increasing.
Yes, it's just constantly increasing, straight line up. Okay? Just one straight line up like that. So for any liquid object, the density don't change, the mass volume graph is one straight line going up. Okay? Okay. Other things than density, obviously I don't even have to teach you lah, you know lah.
What's that?
What are they gonna ask? Which one is the most dense? Obvious.
E.
E? There's no E wake up lah. Hello.
C.
C lah. Okay? Then, of course, if something floats on top, that is the least dense. If this is water, water is 1 gram per cm cube. If I have an object that never sink or don't float at the top but suspended in the center, what does it mean? It means the density is same as the water. Correct. Okay? You'll be just stuck there like that. Yep. Okay? Okay, so very easy. Okay, come. Let's do the calculations. Okay, so turn to this page and do question 1. Everything show proper working. Make sure your units are compatible when you do this, so that you don't make mistakes.